Let's read the question. What is the periodic deposit? So the minute you see the word periodic, it means that you're going to deposit a certain amount of money, which is P, periodically, which means either every month, every 6 months, depending on the problem. So P is the periodic payment. We don't know what it is. That's a question mark. That means we have to answer that question at the end of the problem. What is the periodic deposit that you would put into an annuity that earns an interest rate is given? Let's change it to a decimal first. So 0.0425. So 4.25 divided by 100 because it's a percent. It is compounded monthly. Okay, so it's compounded monthly, which means the number of times it's compounded is 12. And what is the amount you want to collect at the end of, and the time is given, 30 years. So T, the time is 30 years, or sometimes that's also denoted by the letter Y. And at the end of 30 years, we want to collect an accumulated amount of $1 million. Okay. So remember that you do see the words compounded or compound interest in the problem, but remember that this is an annuity because we're talking about a periodic payment here, which is P. In a regular compound interest account, you put a lump sum in, you take a lump sum out, you do not keep putting money into the account periodically, and that's not what it looks like here. So that's an important thing to notice, because that's what will help us decide which formula to use. So the formula that we're going to use for this problem, which is in our midterm handout, is P equals A times R over N, the whole divided by 1 plus R over N whole to the NT minus 1 close parentheses. Now all we have to do is plug in all the numbers that we have. So at the end of 30 years, we're going to collect $1 million. So that's A. That's the future value. R is 0.0425 divided by N is 12. So in these problems, if N, the number of times it's compounded, is 12, then what it means is that the interest is being compounded monthly, and the number of payments will also be equal to 12. So the number of payments is equal to the number of times the interest is compounded. So what I'm doing now is just plugging the numbers in. So I'm dividing by 12, which is N, whole to the, and I'm putting that in parentheses. N is 12 and T is 30 minus 1 close parentheses. Now all we have to do is enter these numbers into the calculator very carefully. Make sure you put your parentheses. Every time you open a parentheses, close it. So you go 1 million. Make sure you're counting the zeros. A million has 6 zeros. Times, open parentheses, 0.0425 divided by 12 divided by, open parentheses again. So we have two of these. The first one is this, the second one is this. 1 plus 0.0425 divided by 12 to the, open parentheses, 12 times 30 minus 1 close parentheses. Hit the enter button and then you get 1,360 $77 and I've rounded it to the second decimal place, 73 cents.